Welcome to the lecture for Homework 9. Here we're going to look at sections 5.2, 5.3, and a little of 5.4. First, in 5.2, we are going to look at rules for exponents, so starting with the product rule. When you have a base being multiplied by the same base, then you simply add the exponents together. So, for instance, here we have 2 and 2, the same base, being multiplied together. So we can simply add the two exponents, p and r, have only now one base, and it is 2 to the p plus r. This is the same if the exponents are numbers instead of variables. So 9 plus 8 is 17. Notice we go from two separate bases to one combined base, and this is only if you have a product between the same base. The base can be letters or numbers. 2 to the third times 2 to the fourth, they are the same base, so then we have 2 to the 3 plus 4, which is 2 to the 7th, and that's 128. Now notice you cannot use this rule if you are adding together like bases, only if you are multiplying. So in that case, you're just going to use 3 to the 5th and 3 to the 2nd separately, and then add them together, and you get 252. Now you do not have to have all your bases the same in order to be using the product rule. You would just use the product rule on the parts that are the same. So for instance, when you're multiplying in number 2, you've got a 5, you've got a 3, you've got an x, different things mixed together. What you can do is group together the 5 and the 3 and get 15, and then group together x to the 4th, x to the 5th, add together the 4 and the 5, and you have your result of 15x to the 9th. Question 3 will be a very similar problem. You're just multiplying 3 separate parentheses together. Next, for the quotient rule. For the quotient rule, it's going to be analogous to the product rule, except that instead of a product, we're looking at a quotient, and instead of adding the exponents, you're going to subtract. So anytime you want to try to practice these before I get to the explanation, I would encourage you to pause the video and do so. See if you can figure out these before I explain them. Here we have the same base, we have a quotient, so then we have v to the k minus h. Similarly here, since we have the same bases and it's a quotient, then we do 16 minus 8 and get z to the 8th. Likewise, if your bases are numbers, you can do the quotient rule as well. 2 to the 8th divided by 2 squared is going to be 2 to the 8 minus 2, or 2 to the 6, 64. Again, you cannot use the quotient rule or the product rule when you're adding or subtracting. You would only use one of these rules if you're multiplying or dividing. So you would type that into your calculator, and PEMDAS rules must be followed. Now notice that when you're looking at a quotient, you can look at individual parts as being grouped together. So first look at 10 divided by 5 and notice that that quotient is 2. So automatically you have eliminated 2 of your possible answers. Next, x to the 8th divided by x cubed. 8 minus 3 is 5. So that would be this right here. 8 minus 2 is 6, and again that would be this one. So we would select this answer. Next rule is the zero exponent rule. As long as x itself isn't 0, because we don't define 0 to the 0 power, but any other number, if you raise it to the 0 power, you get 1. And so if we have z to the 0th power, and you assume any variables are not equal to 0, that is just going to equal 1. If you have any expression raised to the 0 power, the answer is going to be 1. It doesn't matter if it's a number or a letter or a whole parentheses. If it's raised to the 0th power, it is 1, except if you have 0 to the 0 power, which again is undefined. Now this is different than 0 raised to a power. 0 raised to any power is still just 0. So do notice the difference between 3 to the 0 power, which is 1, and 0 to the 3rd power, which is 0. So for this question, we have a parentheses raised to the 0 power, so the answer is simply 1. Over here in question 8, we have various applications of the product rule and also associative rule, a commutative rule, and the 0 power rule. So we've got multiple rules all playing together. So let's look at this problem together. First, you would want to rearrange these variables. At least you would want to group them together in your head separately. The 6 times the 4 you would want to group together, and so that's going to give you a 24. Then you also have x to the 3rd power. You would want to have that next to x to the 0th power. And so when we're multiplying x cubed times x to the 0 power, you can still use the product rule here and simply add the two exponents together. 3 plus 0 is still 3. Or you can just say x to the 0th power is 1 and group it together with 6 times 4. So we have next, we have x cubed. And then lastly, y to the 0th power is 1. So then that is simply going to simplify to 24 24x cubed. Now notice this 4x to the 0th power. The 0 only applies to the x. It does not apply to the 4. There is a significant difference between 4x in parentheses raised to the 0 power as opposed to 4 times x to the 0 power. Because in the first case, 4x raised to the 0 power is simply 1. And that is different from what you have in the second case, which is 4 times 1, which is how we have the 4 multiplied to the 6 to get 24. Okay, now we're working with negative exponents. And anytime you have a negative exponent, you're going to send your expression down to the basement, or down to the denominator is the technical word. And if you have a negative down in the denominator, it's going to send it up. I think of this negative as like an elevator button. If you see it, send it downstairs. If you're already downstairs, send it back upstairs. So what would we have here? In this first case, because we have a negative, we want to make a fraction. We want to keep 1 in the numerator. But then y to the p power is going to get sent down to the denominator. Now notice that the negative is only attached to the z here. It's not attached to the 8. Unless you had parentheses enclosing the 8z, you would have to say that this negative 14 is only applying to the z. So when you are looking at your fractions here, you have to leave the 8 in the numerator. And then for the denominator, you can make this z to the 14 power. If you have a whole fraction raised to a negative exponent, you get to flip over the fraction and get rid of the negative. Everything upstairs goes downstairs, everything downstairs goes upstairs. And so in this case, you're going to take your 7 over 2 and change it to a 2 over 7. And then that is going to get raised to the 3rd power. So all you do is you flip over the fraction and change the negative to the positive. And then you would still have to further simplify that. 2 cubed is going to be 8, and 7 cubed is 343. This is giving me a syntax error because it doesn't want that final answer written that way. I think all you need to do is type in this last answer, even though all that other work is shown. So I'm going to get rid of this other work. And then, see, now it's not angry. Okay, for this next one, we're going to flip over this fraction. And what we'll end up with is the x to the 5th goes down to the denominator, the 3 goes up to the numerator, then we are going to square both the numerator and denominator separately. 3 squared is 9. X to the 5th squared is x to the 10th. Alrighty, so let's look at question 11. We want to group together numbers and group together letters that are similar. So first, if we group together the numbers, when we group together the numbers, we have the 1/7 multiplied by 49, and then we're going to rearrange the x's, so we have x cubed times x to the negative 9. And now we can go ahead and take 1/7 of 49, and then add the exponents. 3 plus 3 plus negative 9 is negative 3. And now lastly, we'll use the negative exponent rule to write the 7 in the numerator and the x cubed in the denominator. And my typing tool was malfunctioning there, so this is what it looks like. Okay, next, the power rule. The power rule is when you have a power raised to a power. This is often confused with the product rule, but notice there is only one base. 2 exponents, but 1 base. And in this case, all you do is simply multiply the 2 exponents together. So here you have y raised to the c, then raised to the d, so that the c times d is going to be your new exponent. Here we have v cubed raised to the 8th power, so 3 times 8 is 24, and you have v to the 24th. Here, 4 times 2 is 8, so we have 2 to the 8th power. And again, this is different than the product rule. With the product rule, you're going to add the exponents because you have 2 separate bases that you are multiplying together. So then you'd have 3 to the 8th power, which is 6,561. The expanded power rule says that if you have a power with a fraction or any combination of variables or numbers, this power is going to apply to every single part. So a gets an nth power, x gets an nth power, b gets an nth power, y gets an nth power. Every value gets raised to the nth power. So in this case, we have CW in parentheses raised to the h power. The h is going to apply both to the c and the w. Here also, the square has to apply both to the numerator and denominator. And here we have the square applied to the 7 and to the x to the 5th, which we have to then make 5 times 2 is 10. And 4 is also getting squared, so the denominator is 16. So we have 7 squared, which is 49, x to the 5 times 2, or x to the 10th, and then 4 squared is 16. Now, this does not work if you have a plus or a minus. If you have any sort of adding or subtracting going on, this rule does not work. You have a whole different set of rules if you're going to square a binomial. And that would you'd use FOIL for that. So to do this one, I'm going to say, see question number 23. Which is not actually the answer, but that's where you're going to look. Okay. Now, we're going to mix together these various properties in the next several problems, applying them multiple steps. So here in question 14, the first thing I want to note is that I have a power rule, so I can apply this power rule. The -5 is going to multiply to times the -4 and also the +4. So then I end up with a to the 20th times b to the -20th. And now we're going to apply the negative exponent rule and send b to the -20 down to the denominator. And then our answer therefore becomes a to the 20th over b to the 20th. In question 15, you need to apply the power rule before you can use the quotient rule. And so what you end up with is, hold on, here we go. In the numerator, you have x to the 12th. And then the denominator is still x to the negative 2. And now you can apply the quotient rule and take the 12 minus the negative 2. Now it's very important to remember that 12 minus negative 2 is not 10. No, 12 minus negative 2 is 12 plus 2, and that would be x to the 14th. See, so if you have x raised to the 12 minus negative 2, remember 12 minus negative 2 is 12 plus 2, and that would be x to the 14th. Okay, question number 18. This is actually a test question. So let's walk through this one step by step. First, we need to observe that this is a combination of power rule, product rule, and quotient rule. And you need to have a separate step for both the power rule and the product rule. Okay, so let me write this. This is very important for the test. You need to have separate steps for the power rule, and I'm going to say product slash quotient rule, because you can actually have the product and quotient rule at the same time, but you cannot combine this step with the power rule, so you need to do those separately. So what we're going to have then is, for the numerator, we're going to start with the power rule, and the power rule is going to have the 5 be applied to both the x to the 4th and y to the 4th. So then we end up with x to the 20th, y to the 20th, and then that is a product with x to the negative 4, y to the negative 20th, and the denominator stays the same. So now what we're going to do is we're going to apply the product rule and the quotient rule. And so looking at the x denominators, I'm going to do the product rule separately from the quotient rule, although you can combine them into one step. Looking at the numerator, x to the 20th times x to the negative 4th, we're going to add together the 20th and the negative 4 and get x to the 16th. And then next you have y to the 20th and y to the negative 20th, and if you add those together, you end up with y to the 0 power. And then the denominator is still x to the 4th and y to the 5th. So now we're at a place where we can apply the quotient rule, and for the quotient rule, we're going to simply do 16 minus 4 for the exponent of x. And then the y exponent is 0 minus 5. Or, alternatively, you can just note that this whole y to the 0 is equal to 1, and so you can ignore that altogether. But if you had done y to the negative 5, because you may not end up with y to the 0 in your numerator, if you have a negative exponent before you write in your final answer, you want to make sure that you rewrite your final answer with positive exponents only. So that means that we need to move that y to the negative 5 down to the denominator and make it a y to the positive 5. So as you can see on the test, when you do this problem, you are going to have multiple steps. At the very least, you need one step for the power rule. Then you could have a combination product quotient rule if you want, or you can have those as two separate steps. And then any cleaning up you have to do at the end is regarding if you have any negative exponents. You just need to make sure that you have positive exponents by the end. Okay, so I'm going to do a separate video next for 5.3 because I've been dealing with some technical issues here. And then we will resume with question 19 then.